So my name is Nick James. I'm the director of the BAA Comet section. And as Andy said, this is our first ever BAA webinar. Obviously being introduced because of the exceptional circumstances that we have at the moment with COVID-19 and most people being unable to leave their houses and all of our meetings over the summer months being cancelled. So the BAA decided that we would set up this regular webinar, and we've got an interesting subject for the first one, which is a comet which I expect that you'll all be hearing quite a lot about in the media over the next few weeks. So this is a comet called C2019Y4 Atlas. It's called Atlas because it was discovered by this. This is the Asteroid Terrestrial Last Alert Service. It's a telescope system that can scan the sky for objects down to about magnitude 20 or so, looking for objects that may be a threat to the Earth, may be impactors on the Earth. It's much more like an amateur telescope than the much bigger surveys that we see, like Pan-STARRS and LSST. So this is a 0.5 meter Wright Schmidt with a very nice detector, STA 1600 detector, which is 10K by 10K pixels. So a little bit more than your average amateur gear, but it's designed to detect objects across the sky down to about Mag 19 or so. And our story starts at the end of December, when this telescope discovered a comet, a very unremarkable comet. It was about Mag 19 and a half at the time, and it was called C2019Y4 because it was discovered in 2019. The Y indicates it was discovered in the second half of December, and the 4 indicates that it was the 4th object to be discovered in that period. In fact, it was the last comet to be discovered in 2019. So comets are pretty unpredictable things when it comes to predicting how well they'll be seen in the sky, how bright they'll be. But fairly quickly, we can usually work out their orbit. So we can at least say where they're going to be, even if we can't say how bright they're going to be. And this graph shows 2 lines. The purple line is the distance of the comet from the sun in astronomical units. So 1 AU is 150 million kilometers. It's the distance from the sun to the Earth, the average distance from the sun to the Earth. So the purple line shows the comet's distance from the sun against time, and the green line shows the comet's distance from the Earth. So when it was discovered, the comet was just about 3 astronomical units, 450 million kilometers or so away from the sun. But when the orbit was computed, the interesting thing was that the perihelion distance, which is the closest that the comet comes to the sun, was actually pretty small. It's 0.25 AU. So that's a quarter of an AU, which is about 30 million kilometers or so. So very close to the sun. So this was a comet which, even though it was very faint when it was discovered, because it was coming close to the sun, had the prospect of being possibly a nice object for us to observe. As I say, we can, with comets, once we have the orbit, we can predict where they will appear in the sky, even if we can't predict very accurately how bright they will be. And this comet is absolutely perfectly placed for those of us in the high northern hemisphere. So those of us around 45 to 55 degrees latitude, which is, I guess, where most people listening to this will be. So the comet is currently circumpolar. It's been moving through Ursa Major, the plough, and it's now just moved into Camelopardalis. And it will stay there until mid-May, when it moves into Perseus. So at the moment, the comet is really well placed for us in the Northern Hemisphere. It's near the zenith in the evening when it gets dark. So we can get a really good view of it from here. Quite often with nice comets, they're really difficult to see because they're far south or close to the horizon. This one at the moment is really near to the zenith for us, so very easy to see. So this is one of my proudest possessions. This is the 6-volume set of cometography. Cometography, a fantastic resource, lists every comet, and I mean every comet, right from prehistory all the way through to 1993. And the fattest volume actually is the one that runs through the 19th century, from 1800 to 1899. And the reason I'm mentioning this is that this comet has very close similarities in its orbit to a comet that was seen back in 1844, so 170 odd years ago. If you look at the orbit parameters here, the eccentricity of this comet matches very closely, as does the perihelion distance, the node, the longitude of perihelion, and the inclination. So we can look in cometography at the description of that comet, 1844 Y1. It was called the Great Comet of 1844. And it was a spectacular object after perihelion. It was seen to have a long tail, a 7-degree long tail. It was second magnitude object in the twilight sky. So what we believe is that these two comets are related. The orbital period of the comets is about 5,500 years, 5,500 years. What we believe is that the comet that we're seeing now, Comet Atlas, and the comet that was seen in 1844, the Great Comet, are both fragments of some parent object, possibly a parent object that broke up at the previous pass around the sun 5,500 years ago. And because of different non-gravitational forces on these objects, the 1844 object came back 160, 170 years ago, and the other fragment, the current one that we're seeing, has only just come back now. So that tells us a number of things about this comet that we wouldn't otherwise know. We know that the comet has been around the sun at least a few times, and we know that if it's a fragment of a larger object, it will have a fresh active surface, because essentially it broke apart at that perihelion 5,500 years ago. So that might inform us a little bit about what this comet might look like. So we know what some comet nuclei look like, and of course this is the famous one of 67P, Churyumov-Gerasimenko. This is an image taken by Rosetta, and we know that essentially comet nuclei consist of ices and dusty material, and that as the comet nucleus comes in towards the sun, those ices turn into gas. They don't melt, they don't turn into a liquid, because in a vacuum they can't do that. They go through a process called sublimation, where they turn directly from ice into gas. That gas flows away from the nucleus from certain active sites. So the nucleus doesn't have, the gas isn't coming from everywhere, it's coming from active sites on the nucleus. That gas flows away, and entrained in the gas is dust. And so when we see a comet in the night sky, what we're actually seeing is not the nucleus. That's far too small for even the biggest telescopes to see. What we're seeing is the material that has come off the nucleus, the gas and the dust. So the gas, both of those form a coma around the nucleus, which we can see, and then both the gas and the dust will flow downstream to form tails. And comets have generally two kinds of tails. They have a gas tail or an ion tail, which is made up of the gas that's come off the nucleus, which fluoresces. It's been ionized and it fluoresces, so it shines by its own light, and that's we normally see as a kind of greenish glow from the comet. And then there's the dust, which is pushed away from the nucleus by solar radiation pressure, and which shines by reflected sunlight. So the dust tail is a whitish kind of tail. So question about the current comet is how big is its nucleus? We don't really know. This is the nucleus of 67P is about 5 kilometers across. Just to give you some example of comets in the past, Hale-Bopp, the comet that we all saw if we were old enough in 1997. When it was discovered in 1995, it was 8 AU from the sun, so that's 2.5 times the distance that Atlas was, and it was already 15th magnitude, so much brighter than Atlas was. It had a nucleus diameter of maybe about 40 kilometers. The famous Halley's comet, 1P Halley, when it was imaged by David Jewett with the 200-inch Palomar telescope in 1982, at that time it was 11 AU from the sun, and it was 19th magnitude at that point. So, and Halley's comet nucleus is probably about 10 kilometers across. So given that Halley was 19th magnitude 11 AU out and Atlas is 19th magnitude only 3 AU out, we'd expect the nucleus to be quite a bit smaller than Halley's nucleus. So maybe even smaller than this 67P. So a number of you might have seen these. The fact that this comet is around is already making its way into the media, and I'm sure many of you use the Daily Mail as your source of astronomical news. I was fearing this was going to happen. Anytime a comet comes along that could possibly be bright, we get all sorts of weird things in the media. This story here, comet 5 times the size of Jupiter, is to light up the night skies in April. It could be brighter than Venus. Well, it could be brighter than Venus. It's very unlikely that it will be. And in terms of 5 times the size of Jupiter, then yes, okay, the coma might extend that sort of size, but it's extremely low density. So very misleading headline, but par for the course really for the Daily Mail. But even the newspaper of record, or at least it likes to think it's the newspaper of record, the Times, with a similar story yesterday, comet of a generation set to light up the night sky. And this basically shows the problem that most media journalists have, that they obviously want to sensationalize the story. They'll look at the sort of absolute extreme estimates and they'll present those as almost a certainty, rather than saying that there's a whole range of possibilities of how bright this comet might be. That's far too boring for them to talk about. So now then, just in terms of how bright might it be, I said that this comet was going to get close to the sun. That's a good thing in terms of how bright the comet might get. It's a less good thing in terms of how close in the sky the comet is to the sun when it gets bright. What this plot shows is the observations that we have so far of the magnitude of this comet. So all of these observations were taken from an online database called COBS, the Comet Observations Database. They're not filtered or sorted in any way, so they are just the raw data that people have provided. Most of the older ones are from CCD and electronic observations. A lot more of the recent ones come from visual observations. We have a very simple equation that we use to fit comet magnitudes, and it's that equation here at the bottom. I'll try and explain a little bit about what this equation means. So it consists of 3, so this is the magnitude that the comet will be. The equation consists of 3 parts. It consists of this H0 parameter, which is the absolute magnitude of the comet when it's 1 AU from the sun and 1 AU from the Earth. So if you imagine the comet was an ideal comet, 1 astronomical unit from the sun, 1 astronomical unit from the Earth, H0 would be the magnitude it has at the time. The last part of this equation is simply encoding the inverse square law related to the distance of the comet from the Earth, which is delta here. So if the comet is twice as far from the Earth, it's 1/4 as bright. And that gets encoded as in terms of magnitudes. Magnitudes are logarithmic in this equation. So 1/4 corresponds to 2 times 2.5, which is 5. The more interesting one is this bit in the middle. This is the thing that says how bright the comet is from a fixed distance as it comes in towards the sun. So effectively, the value n here determines how quickly the comet intrinsically brightens up as it comes in towards the sun. If the comet didn't have a coma, if it was just a lump of rock like an asteroid, then it would only brighten up because of the effect of getting closer to the sun means that the sun is brighter as far as it's concerned. So in that case, it would brighten up as an inverse square law. So in that case, n would be 2. Comets brighten up generally faster than that because most of the light that we see from the comet is reflected from the coma, and the activity of the nucleus determines how big and densely populated that coma is, so how bright the comet is. So what we expect is that n will be bigger than 2, which is a rock, but there are some levels of n which just are unfeasibly big. You can also see there's a problem with using this very simple equation to fit the light curve. You can see that at this point, the light curve fits quite nicely, this orange line here. But around about here, the observations turn over and get flatter. And the comet was about 1.8 astronomical units from the sun at this point. And what we believe was happening is that at this point, the comet still has many, many volatiles on it, which are rapidly sublimating as the comet gets in closer to the sun. At this point, at 1.8 AU, that activity, the rate of increase of that activity slows down because all of these original volatiles are gone, and it now is a different process for it brightening up. And what you can see here is because of this change in slope, if you relied on the original light curve, which is this orange one, you see that it's not actually following this very clearly, very well at this point. So you can do various things in terms of trying to fit observations, fit these observations, or fit a curve to these observations. And there are 4 curves on here. The orange one, which is the Cobb's light curve, which is got an unfeasibly large value of n of 13.4. which would imply the comet would get to about magnitude 17 or so at perihelion, which it definitely will not do. The blue curve is a curve from Jonathan Shanklin, which I received today, which Jonathan can maybe comment on a little bit later, which is just based on fitting the visual observations around here. That still has quite a large value of n, of 8, showing the comet getting much brighter. The 2 curves, though, that I suspect probably are more likely to be realistic over the next month or so are these 2. One of them from Dan Green, which has n of 4, and the other one from Thomas Lehman, which has n of 3. You can see that if we take those curves, we get comet magnitude that maybe is getting about magnitude 6 or so, so kind of naked eye visibility at the start of May, and maybe gets to either magnitude 4 or magnitude 2 at perihelion. Over here near perihelion, the comet's going to be in the twilight sky, so it will be difficult to see. But even if we do get a comet that's kind of magnitude 4 or so through May, it should be a nice object to observe. It'll be certainly an easy binocular object. It should be a naked eye object from places with darker skies. We would hope that it will have a nice tail by then, if the history of the 1844 comet is anything to go by. And we would hope that it would also have become rather more condensed, and so rather easier to see from sites with a bit more light pollution. And certainly it also ought to be a nice object to image in the sky. So in terms of what's going to happen about this comet, we can't really say at the moment. The magnitude we would expect at perihelion probably is going to be about magnitude 2 to magnitude 0. So still quite a nice comet, but in a bright sky. In a dark sky, we're probably talking about a comet that has a magnitude of maybe 3 to 4. We might be lucky, it might be brighter than that, or it might surprise us by turning off tomorrow and effectively fizzling out and becoming a complete dud. That's the trouble with comets. We can't actually predict that. We can predict where it's going to be. We can't predict how bright it's going to be, or at least we can't predict with any great accuracy how bright it's going to be. So it's going to be really interesting to see how these magnitude estimates evolve over the next month. We're currently coming into a period where we have lunar interference, which means that making comet magnitude estimates is quite difficult. So probably it's going to be 10 days to 2 weeks or so before we start seeing good quality dark sky estimates of the magnitude again. And once we get those, we can start to tweak these curves to try and decide between which of these curves is actually the one that the comet is following. Just a few pictures now, just to wrap up. This is a comparison I did the other day between the two comets that are around at the moment. The one on the left is Comet Pan-STARRS 2017 T2. The one on the right is Atlas 2019 Y4. They're both to the same scale, processed in the same way, taken with the same equipment, and show two comets which are actually very similar magnitude. They're both about 8th magnitude, but which have very different morphology. So T2 here is a much broader tail, whereas Y4 has got this very, very narrow gas tail coming out of a very, very diffuse coma. That ion tail is really nice now. This is a picture by Peter Carson. I would say it was taken from Southend, but it wasn't. It was actually taken from his new remote observatory in Spain. So this has got a field of view of about 3/4 of a degree square, and you can see the tail there going out of the frame really. So this ion tail from dark sites with long exposures and good processing is probably a degree or more long now. And we would expect that to get more and more active as the comet comes in towards the sun. Here's an image from Martin Mobley taken just yesterday. This is with a remote telescope, one of the iTelescope remote telescopes, quite a big one. It's the 0.51 meter plane wave remote telescope, again showing that big extended coma and the thin ion tail. What we're really interested in is whether this comet starts developing a nice dust tail, because that's what makes for really nice photogenic comets in the sky, when you've got a nice bright dust tail as well. So we'll have to wait and see how much dust there is in this comet. So we can all kind of hope about how bright the comet might be, and I just put this together to show what it might look like at the end of the second week, beginning of the third week of May. So this is before it dives down into the twilight. So May 18th, you can still see the comet in a reasonably dark sky. We really don't know how bright it's likely to be. It might be 4th magnitude, maybe 3rd magnitude. If we're lucky, it might have a big outburst and it may be brighter than that. And the only way that we're going to know is to keep it under observation. So make observations of it throughout the next few months. But I think we should, no matter what happens, have an interesting comet in the twilight sky. It may not be, as the Times said, the comet of a generation, but it's probably the best comet that we've had for quite a few years. So definitely something worth observing and looking out for. And if you're interested in making observations of the comet, then the Comet Section Observing Guide is available on our website. Just go to the URL that's posted there. You can download it. It contains lots of information on how to observe comets, including how to make visual comet magnitude estimates and how to make electronic estimates of comets, how to image comets and process the images, and how to submit your observations into the various places that collect them, including the BAA Comet Section and COBS. So I hope you will all look out for this comet. At the moment, it's definitely an object that can be seen in binoculars. It's about 8th magnitude. We hope over the next month or so it will become easier to see. It'll certainly be something which imagers will be able to image easily, and cross your fingers that we're going to get an interesting and a nice comet to see in May. But just be very wary of anything that you read in the newspapers, because they will always exaggerate things. And I'm sure we'll see things in the papers about this, and I'm in fact sure that we will also see some sort of connection between comets and the COVID-19 pandemic, because of course comets are bringers of doom and always come along with pestilence associated with them. So I'm sure there will be stuff about that in the media over the next few months. ignore it all and just rely on good, reliable sources like the BAA website to find out what this comet is going to be doing. So thanks very much. I hope that worked well. I think we're now going to be able to take questions. I'm not sure how Andy's going to manage this, but Andy, it's over to you now, I think. Are you still awake, Andy, or have I sent you to sleep? Andy? Okay, so I can see a few people are raising their hands. I'm not sure how I handle that, so I'm waiting for Andy. Andy, are you able to manage the questions? Okay, so I've actually I've got some questions here which I can actually go through that people have posted. So I'll go through them in the order that they were posted. I'm assuming that people can hear me. If anyone can hear me, can they just send a message or something? Or Andy, can you send a message, or am I talking to myself? Okay, great. Thanks, guys. No need to send any more messages. I've just had a zillion of them. Okay, so I'll start going through. So
hi, Nick.
Hi, Andy.
Hopefully everything's okay. I temporarily lost internet over here, so it looks as though everything continued as it should.
It did, I think. We've just got to the Q&A, and I'm just going to go through some of the questions that people have posted.
Thank you. And
so
I'll just stop the recording now.
Okay, fine. So the first question is it possible that 1844 T1 and 2019 Y4 are the same comet rather than a fragment? And the answer to that is no. And the reason is that we know the orbits of both of those comets quite well, and we know that they are long period comets. So for the two to be the same object, it would have meant that 1844 would have had to have suddenly sped up and then slowed down again as it came back into the solar system, so that they both of them look like they have an orbital period of about 5,000 years. So it's not possible for 1844 to have gone round, taken a shortcut and come back as 2019 Y4. So we think that they are probably either one is a fragment of the other, or they're siblings in some way. We don't really know which one is the kind of major fragment and which one's the minor, or whether there was a kind of equal split or whatever. But the orbit is pretty clear that they are definitely related. The orbital parameters are very, very close. Okay, so next question from James Dawson saying, I was talking about how moonlight interferes with making magnitude estimates. And is it possible to use filters like hydrogen alpha to minimize the effect of moonlight on these estimates? Well, certainly filters can be used to minimize the effect of moonlight. The trouble with doing that is that you then affect the magnitude estimate. Comets, if you look at images of comets, and particularly this one, most of the light is in the green part of the spectrum. It's actually swan band emission from carbon species. So you need to be very careful what filters you use, because if you use filters that block that out, then essentially you will severely affect the magnitude estimate you make. Jonathan Shanklin's on the call, I know, and maybe in a minute we can get him on, and he's far more a visual observer than I am, and he can possibly talk about whether it's possible to make reliable estimates using filters. There's a question here, how many people are viewing? I saw a number of 170 odd somewhere. Andrew, I don't know whether you have any more information about that.
Yes, I was taking a look, and if the combined Zoom, well, on Zoom we peaked around 176 and YouTube about 42. So right. Say 215.
That's
or so?
that's not a bad number. I mean, that's probably as many as we get at the Christmas lecture, probably more. So that's quite good, isn't it? I'll just keep going through the questions. Michael Franks asked, how many times has the comet entered the inner solar system? We don't know. We know that it's certainly been back once before because it would have fragmented at the previous perihelion. The likelihood is it's been back quite a few times. Once the orbits are better known, people will be able to do what's called orbit integration on the comet and potentially answer that question. But originally the comet would have come, it's a long period comet, the inclination is 45 degrees or so, which means it would have come from the Oort cloud. We don't know how long ago it came in from the Oort cloud, but it would have been a very long time ago. So the likelihood is that this comet has been around quite a few times, I would think. Okay, so Jeremy here, in fact, connected to that. I said Y4 had been around once. Why do you think only once? If I did say that, I didn't mean it. It's been around at least once. It's probably been around many times. So John Rogers asked, from your slide, it looks as though 1844 comet was not observed until after perihelion. That's a very, very good point. So it's likely that Atlas, like other comets, will not compare with 1844 until after perihelion. That's possibly true. There's been quite a lot of people commenting on that and trying to work out why it was that the 1844 comet wasn't seen pre-perihelion. One possibility is the one that you're alluding to there, in that it was quite faint until after perihelion. The other was that simply people were not so good at discovering comets then. But I think it is a good question as about why the comet in 1844 wasn't seen pre-perihelion. And John Rogers again is correct in saying that post-perihelion, I'm afraid it's a southern hemisphere object. So we won't see it post-perihelion. David Swan, he says, some are speculating that Y4 might disintegrate. This is a good reason to observe it regularly. And is there a way to guess at the probability of such a fate? Well, you can guess at the probability, but whether it would actually be a good guess or not, I doubt. Comets do disintegrate, particularly if the nucleus is very small. If the nucleus is small, the effect of heating as it comes in close to the sun can cause the nucleus to basically fall apart. And that happened with the last comet of the century that you might remember, Comet 2012 S1, Comet ISON, which there was a huge amount of media coverage about this being bright, that being brighter than the full moon at perihelion. So ISON basically fizzled out, but it fizzled out after having a quite nice outburst as the nucleus broke up, and we actually got some nice views of Comet ISON. So it's certainly the point that you never know what a comet is going to do until you go and observe it. One of the reasons I find comets such fascinating things is that you can go and observe a comet and you really don't know what it's going to look like. It might have suffered an outburst, it might be breaking up, it might be very bright that night, or it might have faded. You just don't know, and you basically have to observe it to find out. And that's what we're going to be doing over the next few months. James Dawson asked a question about, is the comet associated with any known meteor streams? I don't think so. I don't think its orbit intersects the Earth, and a comet orbit would need to intersect the Earth to lead to a meteor shower, but maybe somebody else knows that one. There's another question about meteor showers here. And okay, are the magnitude, Dennis Wild has asked, are the magnitude estimates from the light curve adjusted based on the filters used? In the light curve, I showed you the observations were not, they were basically, the reason there was so much scatter is that those observations included visual, CCD, filtered CCD, unfiltered CCD, all kinds of things. If we can get Jonathan on in a minute, he can talk a little bit about light curve analysis and what he does in order to try and get that scatter down. But comet photometry is not an exact science, unlike variable star photometry, where you can get very precise measurements of variable star brightness. Comets are big fuzzy objects, and the magnitude that you measure of them depends on a lot of factors. It depends on the wavelength you're looking at. It depends on how dark your sky is and what kind of optical systems you're using, because the brightness depends very much on the coma diameter that you measure. So we do our best, and we're trying to improve it, but we certainly don't achieve the kind of accuracies that variable star observers do. Right, there's another thing here, which is chat. I don't know whether there are any questions in here. Just let me have a quick look at this.
And also, Nick, I noticed a few people have hands up, like Jonathan Shanklin.
Oh, okay. And so can we get
him to talk?
Yeah, can we do that? That'd be really useful.
Yeah, Jonathan, I'm just going to allow you to talk from this end. Hopefully that's okay.
Hi, Jonathan.
Let's try that.
Oh, I think I can hear you.
Yeah, I can hear you.
Okay, so I'll first go through a few of the points that have come up during your presentation so far. One was the point about meteor showers, and the minimum distance between the comet's orbit and the Earth's orbit is 0.6 of an AU. So that's far too far to create a meteor shower of any sort. So no meteors. There's the point about when comets are likely to fragment. And in fact, pretty much anywhere along the orbit, a comet might fragment. So it isn't necessarily the case that it fragmented at the last perihelion. It might have fragmented on the way to the last aphelion. So that's possibly a point of interest. And of course, there might be other objects on the way in. So a parent body could be on its way at the moment. Then a few other minor points. The tail development is usually better shown in images than it is visually. So if you're out observing visually, you're probably going to be disappointed compared to what is shown in the really good images. And I think for the vast majority of comets, tail development is better after perihelion than it is beforehand. So again, that may be why the comet was discovered post-perihelion rather than pre-perihelion. A small fuzzy patch is much harder to see than a fuzzy patch with a tail. And so finally, on to magnitude issues. One of the key points is that you should always use the smallest aperture that is practicable to see the comet when you're making a magnitude estimate. And with this comet, there's been quite a variety of apertures being used, from around 25 centimeter reflectors down to 7x50 binoculars. And almost invariably, the binocular estimates are much brighter than those with telescopes. And it's possible that something of the standstill over the last fortnight has been created by observers using slightly too large an aperture for the measurements. And as you move to progressively smaller apertures, the comet has been getting brighter. I would be surprised. Go ahead, Nick.
Yeah, sorry, I would certainly agree with that. And the estimates that we've been making using imaging systems, it's very clear that for fairly bright, large comets, you want to use the smallest instrument you can. So either camera lenses or short focal length telescopes. And with those, we've been getting magnitudes that are very similar to the kind of magnitudes that visual observers are getting. But if you use larger telescopes, particularly larger telescopes that have slower F ratios, you don't pick up anywhere near the extent of the coma that's there in the shorter focal lengths, and that significantly affects the magnitude.
Yes, the size of the coma is really critical. And this comet seems to have quite a large, faint outer coma that you don't pick up in light polluted skies. So that's going to disappear as the moon gets brighter and brighter. So it may well be that observations over the next week or so actually show it getting fainter. And then suddenly when the moon goes out of the sky, they may get brighter again. So I'm going to hope that it continues to improve, and that when the moon departs in 10 days or so's time, then we might have a 6 magnitude comet to observe. So I think that's all I wanted to say, unless people have got questions for me.
So there was a question that I was going to hand over to you, which somebody asked about using filters for observing comets, not so much for the morphology, but for making magnitude estimates, and particularly in the context of making good estimates whilst the moon was in the sky. Do you have any comments on that?
In practice, when you use a filter to enhance the comet, it also makes it a lot fainter, because you're blocking out a lot of light. So yes, it is possible to use filters, but you won't necessarily get a better view as a consequence, and you certainly won't get as reliable a magnitude estimate. So I think my advice is you keep using that minimum aperture that shows the comet, and you'll get the best view if you do so. Okay.
So there are a few more questions that have appeared in the question and answer, and then there's some stuff in the chat. So if I start working through those, just to keep going on those, and if Jonathan, if you've got anything you want to add, then please do.
Okay, will do.
Okay, so a question from Andy Sawyer says, is it routine practice to immediately compare the orbit of one comet with that of other historical comets? With 6 volumes of comets to go through, that's a pretty impressive effort. How is it done? It's basically done because there's a catalogue of cometary orbits that's available in a computer readable format. And so in reality, doing the comparison is just a matter of a computer looking for a similar match. Once you've actually found a match, you can go into these volumes of cometography and read up about what the comet was like. But the orbits themselves are all in a computer database, which makes that very easy to do. Then there are a couple of questions, one from Hugh Allen and one from Adam Fairhead, which actually address the same thing. And so basically it's a question about what do we mean when we talk about the magnitude of a comet. So Adam says, when we say second magnitude, do we mean it is as bright as a second magnitude star multiplied across 7 degrees, or is it as bright as a second magnitude star spread across several degrees? And it's the latter. So that's the problem with magnitudes for comets, in that even in a fairly light polluted sky, you can probably relatively easily see, I don't know, a 3rd magnitude star, because a star is a point source. A 3rd magnitude comet, though, can be much more difficult to see. Last year, I think it was last year, beginning of last year, we had a comet around called 46P Vertinen, which I think got to about 4th magnitude, but it was quite an extended object. It was about half a degree or so across. So it was effectively the equivalent of taking a 4th magnitude star and defocusing it over an area the size of the moon. And that was much more difficult to see. So comet magnitudes can be and are quite misleading, and the media often get this wrong as well. You know, they'll hear about a 2nd magnitude comet and they'll think, oh, 2nd magnitude stars are easy to see, but that's not necessarily the case with a comet. It can be. You can have situations where comets are very highly condensed, and so they become easier to see. And we really don't know with this comet, but it is that effectively the magnitude is effectively the magnitude spread out over that coma. Hugh Allen said, would nuclear magnitude be a better measure of visibility? Not really. The nuclear, again depends on how condensed the comet is. The nuclear magnitude, which is the magnitude of the kind of bright point in the middle of the coma, can be a lot fainter than the total magnitude. So for instance, at the moment with this current comet Atlas, total magnitude is about 8, but the magnitude in a 10 arc second aperture is something like 12 or so. So it's not a very good indication either of visibility. It depends on what instrument that you're using to look, really. I mean, I guess you need to think about it in the context of deep sky objects. So you can have, say, a galaxy which can be quite bright. I mean, you think of kind of is it M33, the very big one in Triangulum, which has got quite a high magnitude. It's quite a bright magnitude, but it's spread out over such a large area. It makes it very difficult to see because the surface brightness is very low. Question here from a person called Jim saying, has anyone been able to observe Comet Blancpain lately? I tried the other night but could not see it. I'm not surprised you couldn't see it because it's about magnitude 22 at the moment. This is a periodic comet which has caused quite a lot of jollity and pain this year because the magnitude elements from the Minor Planet Center, which most programs use to predict the magnitudes of comets, have been massively off. It's a comet that can outburst, but it hasn't done this time. And for quite a while, a few months ago, various software programs were saying it was about 2nd or 3rd magnitude, and it was about 18th magnitude. I tried imaging it a couple of weeks ago. I got down to about magnitude 20, and there's no sign of it at all. So you're not going to be able to see that in anything short of a very large telescope. Question again from James Dawson. Can you briefly say what each of the orbital elements you compared between Atlas and the 1844 comet represent? I can if I go back to it. Just do this quickly. So comet orbits are, I hope you can still see my screen. There are 6 elements that describe a comet orbit. So the eccentricity is essentially how squashed it is. So if you think comets' orbits can go from an eccentricity of 0, which is a circle, through to 1, which is a parabola, 0.9993 is a very, very long ellipse. Q, that should be a lowercase q, is the perihelion distance. So that's how far away the comet is from the sun when it's at its closest point. The inclination there is the angle that the plane of the orbit makes to the plane of the ecliptic, so 45 degrees. The other 2 there, the node and the longitude of perihelion, are a little bit more difficult. They effectively describe the orientation of the orbit in space. So they define the point at which the orbit passes through the ecliptic plane, and they define the angle of the perihelion with respect to that point. So those 2 parameters, the node and the longitude of perihelion, effectively tell you the orientation, whereas the eccentricity, the perihelion distance, tell you the shape, and yeah, the inclination then tells you what angle it has to the ecliptic. And the 6th element is actually the time at which the comet comes to perihelion, which in the case of 2019 Y4, I think is sometime on May the 31st. So I think that's all the questions in the question and answer list. Andy, is there anyone with their hands up, or?
We've got a Jack Martin and a Dennis with their hands up, so I could allow Jack to talk. Jack, this is just to let you know I'm about to unmute you. So if you don't want to be unmuted, let me know and I'll remute you straight away.
Hi, Jack.
Looking at his icon, although actually, let me just try again. I think he's still, I've allowed him to talk, he's still muted.
Okay.
So I'll move on to Dennis, and Jack, if you can.
Here. Yep. Okay. Lower hand, and when you go green and raise hand, I should have been actually switched off, but anyway, because you'd expect it to flip and it doesn't. I just want to say thank you so much for this webinar. Excellent, really good. Thank you for everybody who's organised it.
Well, thank you very much, Jack.
Yeah,
and
thank you.
Thank you to Nick as well.
Yes, to Nick, everybody.
Yeah, well, I think, given the situation that we're in at the moment, with travel restrictions and other things, the BAA generally decided that we had to do something along these lines. And so Andy's been fantastic in setting up all the technology and the trustees for getting this off the ground. And this is but the first of many. So don't forget, this is going to be now a regular slot on Wednesday evening at 7 p.m. If you can't make the webinar, you can always watch the video on YouTube afterwards. Dennis, is that Dennis Pierzynski?
It is indeed.
I thought it might be. How's things up in the far north of Scotland, Dennis?
Well, it's just clearing at the moment, so there's a chance of observing this comet tonight again. So that's good. Just a couple of points, Nick, about the visibility of the 1844 comet, which was only seen and discovered post-perihelion. I presume that one of the reasons that it became visible is because there must have been a release of dust. Now, this comet that we're looking at now, the Y4, isn't releasing too much in the way of dust. And so that's probably why, if it was the same situation with the 1804 comet, where there wasn't a release of dust until post-perihelion, then that's probably maybe why we're not seeing it at the moment very brightly. And that could have been the case for the 1844 one. As you know, with McNaughton's comet, although we did see it quite well pre-perihelion, it wasn't till after perihelion that the dust release came and there was a huge tail for it. So that might be one reason why we're not quite seeing much of an object at the moment, because there isn't much of a dust release. Is that how you see it?
Yeah, I mean, it certainly is. It is that dust is what makes a spectacular comet. So, you know, there were two comets back in the late 90s, Comet Hyakutake 1996 B2 and Hale-Bopp 1995-01. Hyakutake was essentially a very dust-free comet. The tail of Hyakutake was a gas tail, an ion tail. And the only reason why that comet was really spectacular is it came very close to the Earth. Whereas Hale-Bopp, of course, had both gas and dust tails, and the dust tail was far brighter than the gas tail was. So it's the dust tail that makes comets really spectacular, not the gas.
And there may have been an effect of forward scattering post-perihelion with the 1844 object that made the tail look brighter as well. Is that right?
Yeah, absolutely. And we know that with 2006 P1, so McNaught, which was the comet you mentioned just now, that was, the geometry was really good for that, and that had forward scattering as it went around perihelion as well. So it's difficult to know, really. I mean, from our perspective, you know, comets are if comets get through perihelion, the very best comets, the most spectacular comets are always post perihelion. They're always immediately post perihelion, when the nucleus has been fried by the sun. So assuming that the nucleus survives perihelion passage, you get really good views. So we're not going to see post perihelion from here. We have to do with pre-perihelion. So, you know, we may be in that situation again that we were in 2007, when we saw quite a nice comet in the evening twilight, and we thought, well, aren't we lucky seeing such a nice comet in the evening twilight? And then a week later, we were all cringing looking at the pictures of this huge arc of tails from P1. Now, this comet probably won't, well, almost certainly won't be as good as that, but you know, there is a high likelihood that if the comet's a bit disappointing here, it'll be much better after perihelion.
Of course, the 1844 comet was a bright, great comet. So this is possible that this could happen post-perihelion.
It is possible, yeah. And yeah, we might all,
I mean, if you hadn't seen the 1844 comet pre-perihelion, you may have put that same prognosis that it's not a great comet, but after perihelion, it was a great comet.
Yeah, that's right. And we might all be looking at our computer screens in June at some really spectacular pictures. But So I'm still hopeful that we will see a nice comet through April and May.
Well, one of the things that has been on the sort of chat web pages and things, websites lately, has been a sort of growing sense of disappointment that this object isn't going to be as bright as it is. I say with comets, you just observe them. They are what they are. They do what they do, and it's our job just to observe them and report.
So yes, I mean, from a diehard comet observer, it's easy to say that, but we all want to see a really spectacular thing in the twilight sky, don't we, with a big tail?
We're talking about a bright object in the sky there. Buses, bright comets seem to come around one after another. Now, there's been another one discovered by WISE this is last few days, with a Q of 0.25 AU in July. And that's going to be a northern hemisphere object after perihelion. Anything to say about that, Nick?
Not really at the moment, other than the fact that there's a lot of chatter about it. We don't really know, but maybe it'll be a subject for a webinar in 4 weeks' time or something like that. But yeah, you're right. Comets sort of come along like buses. I mean, I remember 96 and 97. By how good they were.
And you go back to the 1950s with Merkos and Aaron Rowland.
Yes, yeah, that's right.
Anyway, thanks, Nick, for the webinar. You've done very well there.
That's good. You might want to stay on a sec, Dennis, because there's a question from Dan Fisher on here. He says, and this is, we can all make our guesses, will Atlas be as good or worse or better than Pan-STARRS in March 2013?
I think it'll be something similar. I think that we'll get a similar view to Pan-STARRS in 2013. That's my hope and expectation.
Yeah, which was quite a nice comet in the twilight sky, wasn't it? I mean, it was something that you could take pictures of with a camera lens and get quite nice stuff. Someone here has asked a really good question: why do the Australians seem to get all the best comets? So there's a good answer to that.
Yeah.
Do you want to have a go? It's
no, not really. You know more about it than me.
So the really brightest comets tend to be the sun grazer comets. So the comets that have gone very close to the sun during perihelion and which are very bright post perihelion. And most of the sun grazer comets that we see belong to the same family, the Kreutz group. They're thought to all have come from a breakup of a very large object a long time ago. And since they all come from the same object, they're all in pretty much the same orbital orientation, which means that the majority of these sun grazer comets actually are best seen post-perihelion from the southern hemisphere. So it's not just that Australia is the lucky country in terms of all sorts of things, but they are also the lucky country when it comes to sun grazer comets. Okay. I don't know if there's any more questions or any more hands up.
I can see Jonathan's got his hand up again, and also John Drummond.
Okay, let's go through those. Do Jonathan first and then John.
Okay, am I live?
Yeah, you are. Yep. I can hear you, John.
Okay, it was just a point about the 1844 comet and why it wasn't discovered prior to perihelion. And it's an interesting point from some of the old ship's logs. But in general, for an unknown comet to be found, it had to be brighter than about second magnitude. And that would have been quite difficult to see prior to perihelion. Post-perihelion, it was brighter than that, and so fairly easy to spot when it was discovered. So that's certainly one potential explanation for lack of spotting it prior to perihelion.
Yeah, I think that sounds reasonable.
Nick, can you hear me?
Yeah, Dennis. Yeah.
Well, there's also another point to this, Jonathan, is that when you look at the people who were comet sweeping in the 1840s and look at the names of the people that were looking for comets, you know, Duress and other famous comet observers, they were sweeping for objects and finding objects that were much fainter, maybe 7th or 8th magnitude at the same time. So I just wonder if the comet was as bright as second magnitude prior to perihelion. If it was, these comet sweepers probably would have picked it up, even with a small telescope.
Yeah, that's certainly possible. And if that is the case, of course, then we might have a really spectacular comet after perihelion this time around.
Yeah, possibly.
Yeah, well, that's my my fear, I suppose, is that that's going to happen, and we can't even jump on a plane and fly down to further south at the moment. We just have to rely on people down there sending us pictures. So John Drummond put his hand up. I see there's a message here. He actually managed to image this new comet last night,
Right.
from New Zealand. And he could show us a photo if we could find a way of transferring the file. I'm not sure whether we've got that capability.
Does it show any cometary
Can you
activity?
hear me?
What I was going to do. Hi, John. I mean, what I could do is I can promote John to a panelist, and he can take over if he wishes to then show a photo. Just to note that when you take over and you do a screen share, if you share your screen, we'll see everything on your screen. But if you just share an application like the image, we'll just see the image.
Okay. I must admit, I'm sort of new to Zoom thanks to coronavirus. So
we all are.
Yes. Yeah. I think 2 weeks ago was when I first used it.
Oh, right. So to share my screen, how do I actually do that, please?
Right. So what I'm doing, I've just promoted you to panelist. And when I was doing this in testing on, I think it was Saturday, it took a few seconds once I'd promoted someone, an attendee, to panelist, for them to appear as panelist. And when that happens, you should have a big green button at the bottom of your screen appearing.
The alternative, John, is if you wanted to just email me that picture, it'll probably be here in a few minutes, and we'll take another question, and then you can come back and just talk a little bit about your observations.
Sure. So who's saying email it to me? Is that Nick or
Nick? It's Nick. Yeah. So just,
okay, Nick James. Okay,
yeah.
I'll do that.
Yeah.
Okay.
If you do, and then we'll do that, because as Dominic's pointed out, I need to release the screen in order for you to share anyway. So it'll be easier, I think, if you can just mail it to me. And whilst we're waiting, we can take any other questions that happen to be around, if there are
Sounds
any.
good. I'll send it to you now.
Okay, thanks. So if we got any other comments. Okay, so I don't think we've got any outstanding questions as far as I can see. So we'll just wait for John for a few minutes.
Actually, Nick, can you hear me?
Yeah.
What is your email, please? I for some reason it doesn't pop up when I put in Nick.
Okay. Tell you what, send it to the Comet Observations email address, which is cometobs at britastro.org.
At britastro.org.
I think it is, isn't it, Dennis?
.org. So cometobs at britastro.org. Okay.
That's right. Yeah. So once you've sent it, just ask you a few questions about what you saw.
Sure. Yeah.
Yeah, so that will come to Dennis and myself if you send that.
Okay. All right, I've just sent it.
Okay, so I'll let you know when it arrives. So we'll see the image hopefully.
And I think Dennis has his hand up again.
Okay, Dennis, do you want to go?
Yeah, anything to say about 2017 T2 and what the prospects are for that? Because that's very close to perihelion now, isn't it?
Yeah, it is. So 2017 T2 is a much been around for much longer than 2019 Y4, as you can guess from the designation. It's a nice comet too. It's currently still about 8th magnitude, but it's about as bright as it's going to get. It's again another comet that's circumpolar. I think there is a nice conjunction coming up with M82. I seem to remember sometime, I think it's in May. So it's been a nice comet. It's actually quite an active comet. An image I took of it last night, there's a very clear jet coming out in the sunward direction, which is being curved around and then flowing back down the tail.
Mm.
So if I find those comparison pictures here, I'm assuming you're seeing my whole screen, even though I've got a couple of chat windows over it.
Yeah.
So you can see both of them have got the characteristic green glow from the coma, which is CO emission, so swan band emission. But there's more of a dust tail from T2. And actually, let me see if I can put up the image I took last night. I think I'm sharing my screen rather than, so you can tell me whether you can see this.
See your screen.
Yeah.
Right. Can you see a picture of T2 taken last night? So this is a picture of T2 that was taken last night. This was with a larger telescope, so at a larger scale. But what you can see here is, so this is the bright area of the coma. If you process it, there's this jet coming out that's actually going around and rotating around and then going back down the tail. So it's another interesting comet that's definitely worth observing. I've got John's picture of WISE here, so I will just bring that up. Here it is. Oh, it's very cometary.
That's good.
John, do you want to say something about this picture?
Nice picky.
Sure. Yeah, no, thanks. So basically, I was just doing astrometry. I go to the minor planet comet confirmation page and saw this magnitude 17 object at a declination of minus 45 south. So basically, took about 2 hours of imaging, did 2 hours of imaging of it with a 35 centimeter F10 Schmidt-Cassegrain, an S-Big STL 11,000, a full frame, 30 chip.
Mm-hmm.
And basically this is just 18 of those images stacked together. The images are 1 minute long, and I just stacked 18 of them. I'm currently going to be stacking probably about 60 of the images. I'll do that later today. But yeah, it certainly is quite a cometary looking object. It's got quite a lot of dust around there. In fact, I emailed it to Amy Mazer from WISE, and she's very interested in the image and wants to forward it on to a scientist there who looks at the dust productivity of comets. So I'll send her that later on.
Okay,
that looks a nice image in terms of what prospects this comet's got at 0.25 AU and coming north.
Dennis, how far away from the sun is it at the moment? Do you know?
Oh, I don't know. That's a good question, Nick. That's a good question. You shouldn't ask me questions. Now you're there to be asked questions.
Yeah, yes. When does it come to perihelion?
July.
July the 3rd, and
July the 3rd.
Mike Mayer has just posted on the Comet mailing list that it's then on the opposite side of the sun to us. So it may not be as good as we hope.
Right.
That's a shame.
That's a shame. But in terms of dust, these comets must produce a prodigious amount of dust, because when you look at a comet like 2010 U3, which has been around in our skies for 10 years, and it's still showing dust when you image it, they must release prodigious amounts of dust.
Well, they are. I mean, even though the nucleus is only 5 kilometers across, that's a hell of a lot of mass of dust, and the actual mass of dust in the coma at any one time is quite small. So yes, they're big reservoirs of gas and dust, and that's what makes them such interesting objects, isn't it? Okay, thanks, John, very much for sharing that picture. I think we'll probably be hearing a little bit more about this comet over the next month or two as well. So thanks, everybody.
Yeah, thanks, Nick. That was excellent presentation. So well done to all the technical team and yourself.
Good, thank you very much. Yep, so hopefully everybody enjoyed it. Say the plan is to do this every week now, obviously with different subjects each week. It's an opportunity to keep up the interaction that we would normally have through physical meetings. And I think actually, personally, when this is all over, we want our physical meetings back, but I think we ought to continue with these webinars as well. I think they're a really good way of interacting with people.
And thank you, Nick. That was a fantastic talk, followed by really interesting questions as well.
Yeah, well, thanks, Andy, for setting it up.
And for next week, we've got David Arditi, which, weather permitting, will be showing a live view of Venus, and otherwise we'll be watching a video of it. But fingers crossed for next week.
Okay, thanks, Andy, for setting it all up. Thank you very much.
Thanks all.